Welcome to our channel, The Catalyst. We are going to move to the next lesson, which is lesson 10, and this lesson will be on recursive and iterative functions. Our objectives for this lesson, we are going to understand the difference between iterative and recursive ways of solving problems. We are going to learn how to implement factorials using both recursion and iteration. We are going to compare the structural clarity and the efficiency of recursive and iterative solutions. Okay, so for us to do that, we first of all need to understand what is a factorial of a non-negative number integer. So let's take for instance that the factorial n is equals to 1 when n is equals to 0, and then if n is greater than 0, the factorial will be n times n minus 1 factorial, meaning that let's take for instance that we see factorial of 4. Factorial of 4 is supposed to be 4. The result is supposed to give us 4 times 3 times 2 times 1 equals to, so once we get to 0, it gives us 1. So it's supposed to be equals to 4 times 3, that is 12, times 2, 24, times 1, it gives us 24. So that is it. So what we'll do now is we'll try to write a program for calculating the factorial of a non-negative integer n, and then we'll do that using the iterative function, as well as we'll do that using recursion again. So that is it. Let's go to our programming environment. So what I'll do is I'll put the 2. Okay, I'll write the 2. I'll first of all start by using the iterative approach. Okay, using iteration, what we need to know first of all is that for us to do iteration, we need to use loops to multiply the numbers from 1 to n. Okay, and typically iterative approach is more memory efficient due to stack overheat. Okay, and we also need to understand that with iteration the code is straightforward and easy to follow. So let's dive into the iterative method. So I'm going to call a function. I'll call the function since it has to return integers, so I'll call it int factorial underscore iter, which is the iterative function. And this iterative function is just going to take in the number n, okay, which we'll use to calculate the factorial. So inside now, I will declare a variable result. Okay, I'm going to declare an int called result, which initially will be 1. Yeah, initially it's going to be 1, and then I will use a loop just like we said earlier. So I will give a pointer, I will declare an index I, which I will use for the loop. So I'll use a for loop to do that, and our for loop will start from 1, okay, and it will end at n, I think. Yeah, it will end at n, and okay, and each time we will increment I. Each time we go through the loop. Okay. So inside now, what we'll do is we are going to take result will be equals to result times the number n each time, meaning that since initially the result is 1, when the number will come in as 5, it will say 5 times 1, and the new result will be 5. Okay, and then we'll move to 4, just like that, as we increment it's supposed to multiply it's supposed to multiply that is, will start from 1. It means we'll take 1 times 1 will be 1. Now the second number will be 2, it will be 1 times 2, okay, which will give us 2. Next will be 2 times 3, after that 3 times 4, okay, and so on and so forth, depending on n, until we get to n. Okay, so that is going to be it, and then at the end we'll return the result. So return result that will be considered as factorial. Maybe I will call it, instead of saying result, I may call it fact. Okay, I think it will be better that way if I call it fact. So I will replace all. So it returns fact, which is a factorial. Okay, and then inside the main line, I will declare a variable number. Okay, and I will print a message asking the user to give me the number, which I will calculate a factorial. Okay, so here I may declare a variable called factor for the factorial. Okay, the first thing is I will say enter a number for factorial, or just enter a number, simple. So enter a number, and I will store that number in number, or better still, I'll give it a name, num. Okay, so I'll store it as an integer, is %d, and I'll store it in num. Okay, so I am going to say factor should receive the value returned from the iterative function, this one. Okay, this iterative function. So let me just take this, I'll copy this. So factor will call on that iterative function, which will take as parameter the number num. Okay, and once it is returned, we will now print f, saying what is n, which it was num instead, so we'll say %d, and then I'll put the factorial sign equals to %d. Okay, and the first %d represents num, and the second %d represents the result of the factorial using iteration, so which will be this. Okay, so let's see if it results to what we want. We'll call it factorial program. Okay, so in our example we use 4, so I'll enter 4 and see. Voila, so you see factorial of 4 factorial equals to 24, which is correct. Maybe we'll try another number, say 5. 5 that is 24 times 5 should give us 120. Yeah, if it is 5 factorial. Voila, so it's correct. Okay, so this works for small numbers, okay, small integers. When you start using very large numbers, you have to change the data type of the function, the iterative function to um, long. Okay, so you use long. If on side long when the number is very large. Okay, so we are now going to change this to our recursive function, and we see the difference. So rec, we'll call this rec, and our recursive function, so we'll call this rec. So we'll now see the difference. How do we go about this using rec? So recursive, first of all, we need to know what is a recursive function. A recursive function is a function that calls itself with n minus 1 until the base case is n equals to 0. Okay, so we'll keep on calling the same functions again and again until we get to n equals to 0. Okay, and it is an elegant and closely matches the mathematical definition. So that mathematical definition which we showed in the beginning, yes, when you take the recursive function, they match, they look alike. Okay, well, another thing we need to know is that with recursive functions, they can be less efficient. Yes, they can be less efficient due to function call overhead and stack usage. So, okay, so we'll move now and see how we can represent this program using the recursive function. Okay, so let's see how we can do that. Okay, so using the recursive function, what we'll be doing is we'll keep on calling the function, so I don't even need so many values here. So I will maybe say that I will declare a variable. Wait, there is already int, so I will verify. The first thing is that what is the first condition? When we looked at that our function, it is said that when n is equals to 0, it returns 1. Same as when n is equals to 1, it also returns 1. Okay, so how do we put that condition here? We will say that when n is equals to 0, or when n is equals to 1, yes, what do we return? We will return 1. Okay, else what do we return? Else, what are we going to return? We'll now take the second function, which will say it will return n times factorial underscore rec of what? Of n minus 1. Okay, so that's what we declared. Remember here, over here, that the second option is that it will return n times n minus 1 factorial. And that's exactly what we've done here. So that is it, and then I think that is it. So let's run and see how our result is going to look like. We'll take an example with 4. We'll take 4. So let's say 4, it returns 24, just like we did earlier. So we'll take 5. We'll take number 5. It's still 120, so we see That's the difference between the two. This one is more elegant and very short. Yes, and it reflects directly with the mathematical function. Whereas using the iterative method, it's a little bit longer but more efficient than the recursive function. So, so what we need to know is that both functions correctly compute factorials. It's true that iterative is efficient and uses constant stack memory, while recursive is elegant. Function calls build up on stack until the base case. Yes, so it's a function that calls itself from time to time. Iterative is preferred for performance and large data. Okay, when dealing with very large data, it is better to use iterative than using the recursive method. Recursive is useful for problems defined recursively. Okay, that's easier to understand for me. So that is it. We have come to the end of our lesson. See you in our next class where we'll be dealing with strings. Okay, so thank you very much. And if you have not yet subscribed, please do so. God bless you.